After class, those are for your test corrections, so they're up here on the bookshelf. So after class, if you just want to grab as many as you need, you can fit 6 problems to a paper. But that's what you'll do your corrections on. Okay. Okay. So yesterday we did the limit as x approaches a of f of x minus f of a all over x minus a. Right. That is what we were using for all of these homework problems that we put up on the board. A is an x coordinate. So this is the limit definition for a derivative at a point. That specific point is wherever x equals a. Right? F of x and f of a are y coordinates. X and a are both x coordinates. Yes. Yeah, so like the 2 points that you're using are x, f of x, and a, f of a. So yesterday we looked at this. I had this graph. We could change this to any function that we want. As x approaches a, you get closer and closer and closer to actually being a tangent line there, right? So we were looking as x gets closer and closer and closer to a. But at the end of the notes yesterday, I gave you one equation. It was 1 over x. And I asked you for 3 different derivatives for the same one. It was like f of 1, f prime of negative 1, f prime of positive 1, and f prime of 2 or something like that. And so we had to do basically the same thing over and over and over again. Right? We had to work that problem out over and over again. Yeah. So today I'm going to teach you another method that can be used. And this is the limit definition of a derivative that will give you the derivative at any point. Not just a specific point. Okay? So I'm going to write it down and then we'll sort of like explain what it means. And I'm going to use 2 different types of notation. Our textbook does it this way. Limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x, right? It left me for a second there. It's delta x. Or is it x? It's delta x. It's delta x. I'm going to explain what that is and where that comes from here in a second. Or our textbook uses a delta x, which you've seen some problems with delta x's in them before, which we were actually doing derivatives, but you just didn't even know you were doing a derivative at that point. Yeah. And usually AP stuff tends to use an H instead of a delta x. So this is the same thing as the other formula, but instead of using a delta x, all the delta x's are h's. I like that better, delta x. Yeah. So AP typically uses h's on stuff that they put out on most of the things I've seen that are from recent years. So we'll use that some, but since our textbook uses delta x's, I wanted to show you both. So let's look at what in the world this is and where it comes from. Okay, so let me fix up that. Should have another parentheses there. Okay, so All right, so instead of calling this f of x, or x f of x, and a f of a, like we did on the other one, which I think is a little easier to understand as far as looking at it goes, I'm going to call this point right here x f of x. We did that on the other problem, right? Okay, so I'm going to have some distance h right here. It's going to depend on where I put my point. Okay, so this is some distance h, right? The green line right here. So in this case, it looks like it's a little less than 3. Well, I'd already created this masterpiece of a Desmos. Look at that fancy. Look at that right there. Man, that's fancy. I just made it green. So it is just the distance from here to here. Right? That's just so we can kind of see what's happening here in a second. Ignore it for right now. Okay? All right, so if this point right here is called x, I don't know where it's at exactly, but it's called x, and this distance right here is h, then the x coordinate of this point is going to be x plus h. Okay, so the x coordinate right here is x, and then if I go over this far, which I don't know what it is, but I'm calling it h, then the x coordinate at that point would be x plus h right there. So x plus whatever that distance was. No. No, because x is in this case, like 0.3 or something. Okay. All right, so y coordinate of that is f of x plus h, which is ugly.
Wait,
the y coordinate of this point is f of x plus h. Well, pretty much anytime you have any points, like if I have 3, then I could call the y coordinate f of 3. If I have 7, I could call the y coordinate f of 7. So if I have x, I could call the y coordinate f of x. If I have x plus h, I could call the y coordinate f of x plus h. So it doesn't really mean that we're adding that value there. It's just like, here was our x coordinate, now we're finding the y that goes with it. Does that make sense? So our 2 points that we have, let me clear that off. Our 2 points that we have are x f of x, middle schoolers, and then x plus h, f of x plus h. Okay? So those are our 2 points. Much like our x f of x and our a f of a yesterday. But a f of a looked less confusing, in my personal opinion. But we could still find a slope between these points. So if we find the slope between these points, it'd be f of x plus h minus f of x over x plus h minus x. So what I'm doing there is, this is my y1. This is my y2. So y1 minus y2 over x1 minus.
Why can't it just be simple?
You'll see how this is different from the other ones when we do a problem. But right now, it's going to give us a different result. So I'm going to show you why we would want to use this at some points. Okay. So here, as Addison said, the x's would cancel, giving us f of x plus h minus f of x all over h.
What is
Strange noise there. You're making that with your mouth?
Huh?
Are you making that noise with your mouth? It was.
I mean, I've been like,
Hunter thinks Thomas is so cool because you're like super good at soccer, and he just thinks you're so cool. And so generally I try to encourage this because I feel like Thomas is a good role model. And then occasionally he does things like that, or pulls out he pulls out a granola bar out of his book bag that's been there for 2 years, and I think, should I be encouraging him as a role model? Was it not even Thomas?
Just looking around.
Did you make the crazy noise, or was it something else? No, you're trying to make me think that I'm insane. Okay, well, let's move on to this. Okay.
Well, I don't like them behind me. I don't know.
They're making me nervous too. They're making me nervous too. Okay. So, this is our slope formula. We want to take this h value, and we want to make it smaller and smaller and smaller. Oh wait, I gotta click over here. So we want to take this, and we will make that h value smaller and smaller and smaller, because as h gets smaller and smaller and smaller, as that green line gets smaller, our purple line, our purple dot, will get close to this one. Ignore that the h one over there, I think I've got something kind of wrong with that, but try to pretend like that h doesn't move over there. I think it just has to do that because it's running out of room. It moves to the left. It's really still supposed to be like this little section right here, but I guess because I've got something set wrong. Yeah, I should. As we get closer and closer here, we get a tangent line. So that's
the one that touches one point.
yes. And so what we're doing there is we're doing the limit of this as h approaches 0. So as that h value gets closer and closer to being nothing, then the line's going to approach being a tangent line.
So, doesn't this, it looks like it gives us the exact same thing as the one before.
Okay, so on the graph it's going to look the same. So let's look at what's different about it, okay? Alright, so let's do a problem. So just like this was something that you need to have memorized, this is also something you need to have memorized. With the h or the delta x, it doesn't matter.
No, I mean, it's not even that big of a
What? Let's do a problem first before we get confused by it, because it looks terribly confusing, but it's not so much different than what we were doing yesterday. Okay, so if I want to find, so this question says find the derivative of f of x equals x squared. It does not say at x equals 7 or x equals 5 or x equals 3 like it did yesterday, right? Yesterday we were looking at a specific point. So if I want to know the derivative of this in general, I have to use this formula. Yes, Jack? It is 2x. Did Bruce teach you how to take derivatives? What's the derivative of 3x to the 6 plus 7x? Okay. Okay. Nobody taught you. You don't have too much information yet.
What's the derivative?
Derivative is slope of the tangent line. Slope of the tangent. Tangent line's that line that touches at one point.
Yeah, but like, how do you know that?
So right now, our only way of knowing it is to do this limit definition of derivative stuff. So now, and this is now. So let me just get through this, and now I think I'll further explain what you're asking. I think I know what you're saying. Like,
I don't know what it is.
how can I have? So like here. So the tangent line is that line that touches just at one point.
The blue.
This one right here, which is, I would call it purple, but
The purple.
yeah. So like the slope of that line is your derivative at this particular point, wherever that point of tangency is.
But isn't it the same? Like, it's constant.
It is not going to be constant because my tangent line over here, like right here, if I want to know the tangent line at this point, that tangent line would look like this. It's going to have a positive slope. It's going to be different. If I want to know the tangent point, tangent right here, it's going to have a different slope.
Yeah.
Yeah. So it depends on where you're at on the graph. So, but this one doesn't tell us where we're at. So let's watch what happens. Okay. We're going to use this formula, f of x plus h. I'm going to use h instead of delta x just because AP usually uses that. If you look at stuff in your textbook, they're going to put a delta x instead of the h. Okay, so one thing that, this is a lot, it's similar to the F star problem that you had on your, on the free response questions from last week. So, when I'm finding f of x plus h, it means I'm taking x plus h and I'm plugging it in for the x in whatever my formula is. So, in this case, f of x plus h is x plus h squared. It's just always x plus h. Okay? And f of x is just the x squared, right? So you're going to have the limit as h approaches 0 of x plus h squared minus x squared all over h. And so from here, you're just going to try to simplify and hopefully some h's will cancel. Remember when we were doing delta x problems, we generally wanted us to be able to factor out a delta x and then to cancel with the one in the bottom. It's going to be the same thing here. Yes? Yes. Yeah. And so we will have the limit as h approaches 0. If we square, double square here, square the first, you get x squared. X times h is xh times 2 is 2xh, and then h squared here minus x squared over h. Are we okay with square, double square? You guys? Is the shortcut, the other way to do it would be to write that twice and distribute. Or you can square, double, square. So whenever I say that, to square the first term, that gives you your x squared. Whenever you're trying to like multiply out this binomial here, like this, the two things that are added together there. So you would square the x term, which would make it x squared, because right now it's just x to the first power. You square it, get x squared. Then for the double in the middle, you got to multiply these two together, which will give you x times h, and then you will double that, which means to multiply it by 2. So that gives you 2xh. Yeah, because there'll be 2 whenever you multiply it out. And then square the last, which is h squared for this one. So that's just a shortcut, so you don't have to like show every single step on this, so it'll help. So what happens whenever, after we do that? X squareds are gone. We can factor out an h. So an h is going to come out of the top. 2x plus h over h. Right, these are like the delta x problems that we were doing before. Cancel those h's. And then you're plugging in 0. You're only plugging in 0 for the h, not the x. So you get 2x plus 0, which is 2x. So our answer here, it is a lot like the F star, but the F star was a slightly different formula, but it works a lot like that. The F star was actually twice the derivative, but it's not important for you to know right now. So we would say F prime of x equals 2x. That is the derivative. So this is the derivative of f of x, which is going to give us the slope of the tangent line at x equals any number.
So at any number.
Yeah. So the problems I gave you before, you had a specific point.
I thought it was, the slopes are different at different points.
They are. So if I go to 1 so at x equals 1, f prime of 1 would be 2 times 1. So at x equals 1, my slope would be 2.
And if it was at all 3, then you just plug 3 into the derivative. 6.
If it was x equals negative 5.
So with the derivative, it's not the slope.
It's how you find the slope.
So
Yeah.
does that mean that every answer will have an x in it unless it's like a linear?
Unless it's linear. So if we were finding the derivative of a line of like 2x plus 7, we just get 2 because the slope of that line is 2 everywhere. But anything else that's not linear is going to give us some sort of answer that has an x in it. So if I want to know the slope of the tangent line at 4, I just plug in 4 into my derivative. If I need to know the slope of the tangent line at 12, I just plug in 12 into my derivative. So where this comes in handy, number one, sometimes they're just going to ask you for the derivative, like the answer to this problem is this. So sometimes they ask you for the derivative, and they mean the derivative at any point, so you can't use that other formula that we were using. Because this is the answer. If it just asks for the derivative, you just give this formula as your answer.
You could just use this formula and then plug, like the answer.
Yes. You could still use this, yes. So I show you both because the first one I think is a little easier to understand what's happening. And the other reason is because sometimes on the AP exam they give you like problems that are worded kind of weird where you have to know that definition. I'll show you some of those later. But I could have never taught you what I taught you yesterday. And only taught you how to do that. So like if we were doing this first problem that Selena, if we were doing this problem right here that Thomas did for us, we could have, instead of using 2x squared minus 3 minus 5 over x minus 2, we could have used this formula, the 2x plus h squared minus 3 minus 2x squared minus 3 all over h limits as x or h approaches 0. Don't worry if you're not following everything about plugging that in. But we could have done all of this. We would have gotten that f prime of x equals 4x. And then, since they're asking me about the point 2, f prime of 2 equals 4 times 2, which is 8, which is the same F prime means the derivative, so yes, you want to. Once you get that, yes. Tangent lines are always linear, but they don't have the same slope at every point. Let me see if I've got a decimal graph on this to kind of like explain what I'm talking about here.
So the equation. So the equation in green. Sorry. The equation in green we use if we have like points, like we want to find an exact point because it's easy.
Yes.
But the one in purple, if we don't have an exact point, it's just a general thing for the whole graph.
Yes. Okay. So, all right. Let's see if I've got.
I really want that.
Let's see if I've got one already made here. Tangent line. Let's see about this. Okay. So, for example, here, I've got this. This is a really cool graph, and I love it. Sine of x plus 0.3x. It makes such a cool graph. It's like a wavy stair step of a thing. But it doesn't matter what the graph is. Like, at this point, when, let's say, x equals 2, my slope is negative, looks like it's negative 1/4, I think. Let me zoom out a little bit, so. No, negative, yeah, negative 1/4. No, not negative 1/4. Either way. I've got a negative slope right there. So, if I plugged in, I would get that. But here, my slope is even steeper and negative, so it'd be like maybe negative 2, negative 1, something like that. Over here, I have a positive slope. Up here, I have a 0 slope, right? So, at every point of the graph, we have different slopes. So, let me change this to the one we're looking at, which is x squared. Yeah. So, here's x squared. Let me move this back down where it's actually where we can see it. So, like what we just found, everywhere we look at, so like if I go to where x, let me zoom out a little bit. If I go to where x equals 1, hopefully I'm, well, here, let me change this where it only goes up by 1. All right, so if I go where x equals 1, notice because the slope of that line is 2. But if I go over here to where x equals 2, the slope of this line is 4. If I go over here to 3, it might be too steep for me to actually see. I think I can though. I've got the slope of that line is 6. If I'm over here at negative 1, I got a slope of negative 2. So, and we could even do the like decimals in between. I'm just trying to pick one. So the slope is different at every point on that graph. And this formula right here gives me the slope of the tangent at any point on that graph. Okay, let's do another one.
So, the slope is root. It's like the derivative is the ladder.
Say that again?
We gotta find the ladder. I don't understand that.
Okay, yeah, you could say that. You could say that. It's like a ladder that's touching the rope. Yeah. At one point. At one point. Yeah, okay. Okay. All right. Okay. All right, let's look at this one. Okay. So, I've got x cubed plus 2x here. So, that is my formula for my equation. So, if I'm looking at the graph, this time, x to the third plus 2x. Plus 2x. Is that what I have? Here. Plus 2x, yes. So, this is the graph that I'm looking at. It's a very skinny cubic right there. But, you know, I could be looking at tangents at any point on that graph. Tangent's the red one. It's the tangent is always a straight line that touches the graph just at one point. The graph typically is going to be something that's not linear, although it could be.
Whenever we're doing this, are we finding the tangent, or are we finding the way to find the tangent?
We're finding the way to find the slope of the tangent. slope of the tangent is so like the slope of this line is just a number. So like if I'm like down here, like the slope of that line might be 5, I think. So slope of the line right here is going to be 5. But the equation for that line would be something like y equals 5x minus 2. It's the equation of the tangent line. The derivative is just the slope. The derivative is a single number. If at this particular point. Yeah. At this particular point. Okay. So let's do this one.
The next problem looks like it's going to be a very, very long.
So I got the limit as h approaches 0 of f of x plus h minus f of x over h. So when I've got to do f of x plus h, yeah, you got to put the x plus h in both of these places right here. So it is actually x plus h cubed minus or plus 2 times x plus h. And then you still have to have minus f of x, which is x to the third plus 2x all over h. Oh, Daniel. Okay. Oh. Okay. All right. So what we've done here, this f of x plus h, that's this part right here, where we just plug x plus h into whatever the formula was. This part right here, that's just the equation. And then it just always has an h in the bottom. H is just a distance, and we want that, it's like a distance from point to point, and we want that distance to go away. We want it to be 0. Yeah. Alright, so, let's see. Girls' homework is from that same page. Yes. Homework is, it's all on that same page from last night. So if you've already got a picture of it, you're good. Okay. All right. So x plus h to the third is a pain. I'm gonna show you a trick tomorrow on a little bit of a shortcut here, but I don't need to add something else in on this question already. So x plus h to the third is x plus h 3 times. So you would like to multiply these two together. So yes. So you're going to multiply this together, which is going to give you h squared plus 2xh plus h squared. We can just double square that. But then we have to multiply these two together. Yeah, so we got to distribute here. X times x squared is x to the third. X times 2xh is 2x squared h. X times h squared is xh squared. Then we must also distribute the h. That's going to give me plus x squared h plus 2xh squared plus h cubed. And so you do have some like terms that you can put together. You got this x squared h here and this x squared h here. So you're going to have x to the third plus 3x squared h. you also have this xh squared and this xh squared. So that's going to give you plus 3xh squared. And then you got your plus h squared, or h cubed on the end. So all of that stuff is just this, what was in that green box. That's all of it expanded. So it's a pain. I'm going to try not to give you too many for homework that have something to the third power. So we still need, I'm going to distribute this negative. We still need minus x cubed minus 2x all over h. We should have things that cancel, because when you're doing these problems, x to the third cancels. What else cancels? Hold on. I think oh, what have I done? I did the wrong, I have forgotten something. This was actually, this I circled in green was actually just this part.
No, 2x.
So, oh, you can see how bad these are whenever you got x to the third. I know. So I needed to distribute that 2 and get plus 2x plus 2h, and then the minus x to the third minus 2x. Yeah, if you want to put it on the end, that's fine. So we've got that. Then this 2x and the negative 2x should cancel. And everything without an h should cancel. If it doesn't, you've done something wrong. So everything left in this numerator has an h. So I'm going to go ahead and factor out a h. So I got 3x squared plus 3xh plus h squared plus 2 all over h. Limit as h approaches 0. So h's cancel. I'm going to plug in a 0 for my h. So that's going to be 3x squared plus 3x times 0 plus 0 squared plus 2. Essentially, whenever you do that, anything that still has a h with it goes away. And so I get 3x squared plus 2. And this is your f prime of x. That's your derivative. You can shortcut it. All right, what about 6x to the 5th minus 2x? What if I, okay, x to the 5th minus 2x. Not 4x. 5x to the 4th. Yeah.
Is it like a pattern?
There is a pattern. You do have to know how to do this limit definition of the derivative way, but you're getting there. Yeah, you're getting there. Yeah. Eventually you'll be able to do all of them shortcuts. You have to know limit definition of derivative. They put these questions on the test.
What if it's only one of the free response questions?
Now I can tell. Now if you were like me, I could tell you this is going to be 1 over 2. Let's see. 1 over 2 square root x plus 1. I'm pretty sure. I think. Let's see if I'm right on that. Might not be. Okay. All right. Here's some different notation you might see. So this right here, d over dx, means take the derivative of. Okay? So d over dx, square root of x plus 1, it means take the derivative of. So it is the same directions as find f prime of x, but they're giving it to you in a different notation. Okay. So, essentially they're telling you that f of x equals the square root of x plus 1, and we want to find f prime of x. That's what it means when you see this notation. So we need to use that formula, limit as h approaches 0, of, I've got to do f of x plus h. H always approaches 0 if you're using this formula. Because that distance between the 2 points is that green line. We want it to get smaller and smaller and smaller. Alright, so if I take x plus h and plug it into that equation, I would have x plus h plus 1. So on my formula, you know, we have f of x plus h minus f of x over h. So for this part right here, let's do that in green. For this part, we're just taking x plus h, we're plugging it in for the x just like we did on the other problem, which gives us this. So we put it, we're going to put it right there. So we're going to have limit as h approaches 0 of square root of x plus h plus 1. Fine. I was just showing you that that's what the question's asking. So minus f of x, which is just the equation, square root of x plus 1, all over h. Okay? Alright, so how do I solve this limit?
I'm assuming you multiply by the reciprocal thing.
Not reciprocal, but conjugate, yeah.
Whatever the word is.
So conjugate is just whenever we write it exactly the same, except we change that minus to a plus. And we must multiply on the top and the bottom. Okay, here. So, we distribute. What is the square root of x plus h plus 1 times the square root of x plus h plus 1? It just cancels out the square roots, x plus h plus 1. Okay? Now, the reason we chose the conjugate is because whenever we do the outside terms and the inside terms, they're going to cancel out. Especially on this one. I'm not going to worry about writing those down. They will cancel out because it would be the square root of x plus h plus 1 times x plus 1, which would be long and difficult to write. But they will cancel out. And then we will multiply the last two terms. What's the square root of x plus 1 times square root of x plus 1? X plus 1. Make sure you subtract that. So you would have to distribute that negative. All over h times square root of x plus h plus 1 plus square root of x plus 1. And this is limit as h approaches 0. Luis and Selena, you're probably going to watch the recording because this probably does not make much sense. Alright, so you distribute that negative, which is going to give you the limit as h approaches 0 of x plus h plus 1 minus x minus 1 over h times square root of x plus h plus 1 plus square root of x plus 1. And so x's cancel, 1's cancel, leaving only the h on top. So that h I couldn't cancel from the beginning, but now that the other stuff is gone, are you guys alright if I just cancel it now? So we don't have to write that again. And so we have like a 1 here on the top. Alright, so if I plug in 0, I'm going to get 1 over the square root of x plus 0 plus 1 plus the square root of x plus 1. And so that's 1 over the square root of x plus 1 plus the square root of x plus 1, which is 1 over 2 times the square root of x plus 1, which is what I said it was in the beginning.
Whoa.
So eventually you will learn a shortcut
What is the
good enough that you can do that in your head. But right now you can't do it in your head because I'm not going to tell you
So
yet.
are we going to go home and do like 20 problems to this, and then let's come back and close it? There's like a crazy simple shortcut for us to do. You want to take 5 hours to do this? Yep.
AP gives you limit definition of derivative problems on the test, so we have to learn how to do it this way. But we won't have to do it this way forever. We want to just take the L on some of those problems. So this is your F prime of x.
So if it was like, if you wanted to find a slope of the tangent line and x equals 1, you just plug in 1.
Correct. All right. Questions on this? Okay. We are going to put this off a little bit here because I don't want to get into finding an equation of tangent lines with 7 minutes to go. So let me adjust your assignment accordingly. I might definitely take some of these off. I was giving you, we might just have to change the assignment actually. Because I was going to do, all of those are tangent line problems. Yeah, okay. We're going to do that stuff eventually. We're going to do some of it, but let's do page 131. Let's do 11. 11 through 23 odd. Okay. You don't know how to do the other ones, so. Okay. Yeah, they're odd. It's 1, 2, 3, 4, 5, 7 problems. It's doing what we were doing today. So you're using, for all of these, you need to be using the limit as h approaches 0 of f of x plus h minus f of x all over h. So for all of these, you have to use this formula. The first one should be easier because you have smaller numbers. 19's got a cube on it, so it's a little tougher. So you'll be doing the limit as h approaches 0. So f of x plus h, this one's a little bit. So if f of x is just 7, okay? What is f of x plus h? It's also 7. So you would have 7 minus f of x, which is 7, all over h, which is going to give you 0 over h, which, and this is number 11, so. But we're going to get 0 over 0 here. So let's stop and think. Because algebraically, there's not anything else we can do to this. We already just have 0 over h.
Oh my Lord. It just kept going.
That thing fell like 3 times longer than it
You might should go check on it. Alright, so f of x equals 7. What type of line is that? What kind of straight line? Horizontal line. The derivative is the slope. What is the slope of that line? It is 0. So for that one, f prime of x just equals 0.
I wouldn't have been able to do the first problem.
So like you don't have to do 14.
If the equation is linear, then it's just a slope. Like, it just will always be that.
Yeah, you don't have to do 14, but 14 you got 7x minus 3. What's f prime of x?
The derivative would just be 7, right?
Because the slope of that line is 7 always. So you can shortcut it if it's linear. But if it's not linear, then you're going to have to...
I'll find out.
I mean, the shortcut's super easy, but you still have to write it out and do it limit definition. I will not give you credit on... I'll let you shortcut the ones that are linear.
What if it's, how do you know?
Linear is like y equals mx plus b. Yeah.
You just double check.
Yeah.
I'm not laughing.
So if it's y equals mx plus b, it's linear, and so linear lines obviously just always have the same slope, so it's just whatever that slope is. But if you got like a quadratic or a cubic or 1/x or square roots or e's or anything like that, yeah, rational, all kinds of crazy stuff. Those you have to do the limit definition directly. So really, there's only 4 on there that you have to do the whole thing for. Yeah, I just did 11. So I feel like that's reasonable.
I don't.
Yes, I do need to see yours. And yours does not exist. I saw it was. Thank you. And Selena, that too. Okay, good. Thank you. I will be here in the morning.
I
Yes.
can only stay for 10 minutes.
Oh, in the mornings. That is really not worth your time to come over here, is it? Can you stay after any, or have you got stuff right after?
I go.
Probably just call me at like, actually no.
By the time I even get around so I got twice a week.
And you're at internship. You want to come up here and eat lunch?
I can try.
Yeah, like if you want to just get lunch and bring it up here, I usually eat in my room so I can help you with some stuff in, maybe. Since we seem to be really running into... I mean, I don't mind you coming in the mornings, but I don't want you to come over all the way over here for 10 minutes and then have to go leave, you know.
I'll come for lunch.
Yeah, come for lunch.
All right. Thank you.
You're welcome.